Hey, what's going on YouTube? We should be live right now. How's it going? Welcome back to my practice stream. If it's your first time, my name is John. I am a practice streamer. I used to, I still do, but my priority used to be streaming my hobby in classical guitar. Now my priority is streaming mathematics. I'm a former mathematics major. I studied pure mathematics a long time ago, from 2007 to 2012. Then I decided, holy crap, this looks like a really hard way to make money, and I'm not quite good enough at it to go to grad school, so I decided to go into software. I worked for 10 years in FANG companies. I went from Apple to Lyft to Google. And then I have an argument that AI took my job, but it takes time to explain why. Now I am becoming a YouTuber, apparently. That's the dream, but the realistic path is that I'm trying to become a high school math teacher. And really, ideally, I want to do both. I think it's possible that I could just do both. Why not? How's it going, Ta3575? Good morning. How are you? If I didn't say it already, we are live right now. In my opinion, it doesn't count unless it's live. Like if you're teaching a classroom, or if you're giving a guitar concert, you don't get to go back and edit and take out every time that you said and things like that. Like you need to be able to speak correctly the first time, right? So I'm practicing. I used to say all the time, and I think I'm getting better at it. I need to learn to speak faster, though. When I watch my videos, I'm like, oh my gosh, I'm kind of drawling a little bit. I grew up in the South and whatever. So please, feedback is a gift. Let me know what's going well, what could be better about the stream. Today, we're going to do calculus. It's the third day, and then tomorrow we're back to linear algebra. Let's get into it. So today I want to try to get a little more efficient. I apologize in advance. If Taalman ever finds this video, please let me know if you want me to stop just copy pasting the exact problem statements or doing anything. You know, like if you all don't like the idea of me just being a weird, like, fanatic, like a stan, you know, like the Eminem song, like a stan about this book. I love this book so far. And I'm just slowly working every single exercise from this book on the internet, live, making mistakes as a hobbyist. I think you have had a great rhythm voicing already. Well, thank you, Ta. That means a lot. That really does. And 3 Mizzy, what's up? Sometime we'll get chat back up on screen, but not today. All right, so we've got 4 squirrels living in Linda's attic. If she does nothing to 4 squirrels in an attic, if she does, dude, if you have squirrels or any kind of animals in your attic, you gotta get rid of them, dude. Man, like, I've been reading about people who have been bitten by bats recently. Like, dude, if you ever see a bat, you need to move. Like, man, rabies is intense. Like, oh my God, do not live with rabbits or not. I think rabbits are probably fine, but I don't know if squirrels can carry rabies, but I'm not personally okay with living with a bunch of squirrels, especially after reading about bats, right? Okay, so somebody just already calculated, I think, that we're going to get 272 squirrels. Let me understand why. How can I call myself Batman if I don't live with bats? That's a good question. I don't want to be Batman either, dude. Like, that sounds like a bad idea. Okay, so there's 4 squirrels now, and there's going to be 275 at some point. If she does nothing to evict these squirrels, which she better freaking do that as soon as possible, the number of squirrels in her attic after T days will be given by this formula. S of t is 12 plus 5.5t, 3 over 0.25t. Part A, verify that there are 4 squirrels in Linda's attic at time t equals 0. So, for part A, we're going to do S of, I think red shows up poorly, like really pixelated for you all, which is unfortunate because it's like the accent color of this book, right? So if you all get annoyed, I'm a front end iOS engineer, so I care so much about like pixel perfection. Um, so I might be the only person in the world who's currently annoyed. Like if I didn't mention it, you all might not have noticed this until right now, but it drives me crazy. Oh well, let's try it with red. Just tell me if you all want me to change colors. Verify 4 squirrels at time t equals 0. So what we're going to do is instead of t in this equation, um, we here let me try some crazy stuff. So I'm always like practicing here because I think that this would be a really cool way actually to teach in a classroom. Like give me a TV, I'll bring my own Apple TV and we can just AirPlay and I'll sit in a chair and play classical guitar music in the background while I work problems, right? Like, dude, I think that a lot of this could translate over. Okay, so we've got this expression 12 plus 5.5t over 3 plus 0.25t. Okay? All I did was just recopy this. I just want it in my own handwriting for a second. We're going to find what happens. Well, we're going to confirm that when t is 0, there should be 4 squirrels, exactly like the problem says up top, right up there. 4 squirrels. Let's just make sure that that's true. So at t equals 0, we're going to substitute everywhere where there's a t, we're going to replace it. Oops. Everywhere where there's a t, we're going to replace it with a 0. So we had a multiplication by t. In the denominator, we have another multiplication by t. And I'm just substituting. I'm replacing all of those symbols. Where there was a t, now there's a 0. I know that this is simple math. Somebody calculated the answer in like 3 seconds, but my goal is that this stream can be accessible to everybody. And I tutor little kids, and sometimes some people still have trouble at some point, like internalizing like what we mean by substitute the variable. And I think that like I'm learning ways that I can use technology because I'm a techie to try to make some of these ideas more clear, right? Okay, so now, well, anything times 0 is just 0. So what we're left with is 12 divided by 3, and that's 4. So, done. Part A, done. Determine the number of squirrels in Linda's attic after 30 days, 60 days, and 1 year. I like this book, man. Like, I like how in part B of this question, there's 3 parts. Like, this book is nice. And it's like conceptual. Like I geek out about design. There's this yellow book behind me, and I'm reacting to this book slowly, day over day. Bro, which book? It's called Calculus by Taalman and Kohn. It's an excellent book so far. I really like it. I like it so much that I found a PDF online, but I still bought it because I want to support the artists, dude. Like, support artists if you can, if you have the privilege to. But it's an expensive book, so, you do you. Verify that there are 4 squirrels in the attic. Determine the number of squirrels in the attic after 30 days, 60 days, and 1 year. I'm going to double check for myself that right now, I didn't circle this earlier. Yeah, T is days. So it's not like they tricked us and went from seconds to days, because 0 would be 0 in either case. Whatever. Part B. So we're going to do the same exact approach, substituting 30 days, 60 days, and we do have 1 unit conversion here of 365, which is the same as 1 year. Bro, what's your goal behind this learning? Thank you for asking. You're giving me some content I can react to. Thank you, dude. Vedant, is this your first time here, bro? It's nice to meet you. You probably would have heard this by now if you've been here before. Um, what's your goal? Right? What's your goal? Um, I want to make money, dude. I'm unemployed because AI took my job, and I want to make some freaking money. Uh, I love mathematics. I'm privileged and I'm in the position where I can take a risk and try to build a freaking business. I want to build, man. I want to build a really cool YouTube channel, a really cool community. Um, but it's a lottery ticket. It's very unlikely that somebody can make money off of YouTube. I expect that I'll never make any significant money at all from this channel. I want to get hired as an awesome high school teacher. So um, yeah, I wanna work at a fancy magnet private school or public or private school. It doesn't have to be private, but like I want to like work with like awesome kids who are either good at math or just motivated to learn. Like I want to teach the little children. I want to teach, the incoming freshmen, the incoming class of the next generation of awesome mathematicians cuz I couldn't make it, but maybe I can teach other people too, right? So quickly let me also give this little um, history. Bachelor's in math, pure math, 2012. Then, I mean, I'm going to skip some details here, but later I worked at Apple as an iOS engineer. I worked on iMessage. Then I worked on payments at Lyft, um, which is kind of like Uber. If you're international, you might not know Lyft. And then I worked at Google, specifically at YouTube. Um, and now I want to go back to math. Let's just keep it simple. So there's my little path that you might be interested. Bro, then don't solve. Just do some like research and reaction. Eh, have I convinced you yet that this is more interesting? If not, you can go away. I don't care. I mean, this is niche. Like, I know that this is niche. Like, live streams are super niche. But my goal is to practice, dude. Like, I geek out about practice. So, what's your goal? I want to practice in order to teach, you know? Damn. What do you mean, damn? All right. Well, it's nice to meet you, Vedant. Thanks for asking. Um, I just reacted, bro. You just said that I should react. I just reacted, dude. I could clip this if I wanted. This would be a cool clip. I'm too lazy. Let's keep going. JC is also top 10 Swifties in mainland USA. Um, I do like Taylor Swift, but not that much, dude. Not that much. All right, so I personally, okay, so I'm gonna let you all here. I'll read this comment. Arad, it's good to see you. Yeah, I mean I love blackboards too. There's something so traditional. I accidentally read it. There's something so beautiful about the tradition of a chalkboard. Um, I mean, right now, like practice. Like, I think that this is a way to practice blackboard math, right? Like, I mean, it's black, and I'm writing in white letters, right? And I'm having to like explain out loud and write at the same time, and choose how much to write and how much to speak. So like, there's some chalkboard experience happening right now. You know what I mean? I don't think that this YouTube would be very good or entertaining if I had a physical chalkboard. Maybe someday, who knows? All right, so Vedin, I hope you appreciated the answer. Nice to meet you. Let me know. Feedback is a gift. All right, let's keep going. So, deliberate, like if there's any topic that I geek out about and I want to study deeply at like a research level, I want to study like deliberate practice. Like I want to study deliberate practice itself, not just in math, not just in guitar, but kind of like a general theory of deliberate practice. So, okay, Vedin is just like okay, good. Thanks, man. It's nice to meet you, man. All right, let's keep going. All right, S of 30. I'm gonna do the same thing. 12 plus 5.5 times 30. Let's try to get the right level of. I need to get one of these new fancy calculators. 5.5. I could do this in. I should do this in my head. All right, 5.5 times 30 is going to be 615. Like, dude, we can use our brains here, and we can practice that. Is that right? No. What am I talking about? 165. That's what I meant to say. 165 over 3 plus 7.5. Right? And that's going to be 177 over 10.5. And that's going to be approximately 17. It's going to be approximately 19-ish. 177 divided by 10.5. Nope. Oh, I went the wrong direction. Yeah. 16.86. So there's going to be about 16 squirrels, dude. 16 squirrels already. Bro, you got to watch out about the squirrels, man. Take care of the squirrels. Dude, that's after only 30 days. Like, what? Okay. I wonder how this... Let's think in advance. Let's think in advance about this model. Because it's impossible. Like, every model is a lie. Like, every model is just like an abstraction of the real world. Like, mathematics is this beautiful, logical, beautiful, ideal world. But like, it's impossible to have like 4 billion squirrels in your attic, right? Like, eventually this function, I think, I have to think about it for a second, which is the point here. Eventually, some of these functions are going to say that there's like 1 billion squirrels in your attic, and that's just really silly because there's not even enough space. Like, every squirrel takes so much volume in space. I can go on stupid little tangents like this, but go. The automatic cat feeder went off, so she just went crazy. So obviously this model is going to break down at some point. And who knows, maybe that'll be like the last question, which would be really cool. Like, when does this model stop making sense? Like, give a number of days where this model is just really, really silly. But let's try to do a little bit of analysis, just thinking and looking at the thing. Dude, at some point, there's so many squirrels that there's no food left in the attic, and they're going to start starving, and they won't survive anymore, right? Like, at some point, there shouldn't be enough food to support, like, 1,000 squirrels. So a function, an accurate model of the number of squirrels in your attic should go up, and then it should go down. And maybe it goes up and down. But let's use our math skills for a second. As the numerator gets large, it grows faster than the denominator. But both of them keep growing. Both of them get bigger over time, right? And the numerator grows more quickly than the denominator, if you think about that. So, like, 100 days later, it's easy to multiply by tens. You just move the decimal. 100 days later, there will be about 550 squirrels in the attic, and there will be about, or wait, no, sorry, there will be about 550 divided by 25, right? And yeah, I think you get my point. Like, so this function is going to keep growing, and I can tell that at some point these numbers are going to be silly. Like, I think Arad or somebody pointed out, I think maybe the last one is just like, that's kind of funny to imagine. So you have to look for the humor, I think, in math problems. Because, like mathematicians are really subtle with their humor, but there's always, like, some stupid little funny humor in here. Like, the next question might be like, well, what about in 10 years? How many squirrels are in your attic, dude? Okay, let's keep going. So we have, all right, so how am I doing 5.5 times 60 in my head? Well, I know 5 times 6 is 30. So 5 times 60 is 300. And then what is half of 60? It's 30. So 330 plus 12 is 342. What's the denominator? Half of 60 is 30. Half of that is 15. Plus 3 is 18. And now I can ask ChatGPT, 342 divided by 18. I could try to estimate that, but let's just keep going. 342 divided by 18 is 19 squirrels. Okay, it didn't quite grow as fast as I was hoping, but let's see. What about in a year? How did we... Maybe I did a mistake. Did I make a mistake when I was trying to show off my mental math skills? 12 plus 5.5 times 30. Oh my goodness gracious. Oh wait, no, that's right. 177, that's right. Half of 30 is 15. Half of 15 is 7.5. Yep, okay, I think we're good. Like, how do we go from 4 to 30, or 4 to 16 so quickly, 4 to about 17 so quickly, and then, yeah, okay. So this function grows more quickly. If it grows more quickly, but then it's going to become linear eventually, which is neat. And I can explain at some point why I know that. But it grows quickly, and then it becomes linear. Neat. 365. Let's just ask ChatGPT. 12 plus 5.5 times 365 is 2,019 and a half. Halfway through 2019, we were all living our best lives, and we had no idea what was going to happen next. 3 plus 0.25 times 365 is 94.25. 2019 and a half divided by 94.25 is 21.43. Okay, 21.43. Neat. Okay, so this isn't quite growing as fast as I was hoping for. If I were a textbook author, at least in the section of exponential growth, I would include that, like a really really silly example. But still, this function is going to grow linearly over time, and yeah, where are we? So, maybe I'm wrong. I mean, maybe there is a limit value. Is there a limit value? Oh, there. No. Yeah. What am I talking about? It doesn't grow linearly. What am I talking about? I was misreading this as t squared in the numerator. No, this function grows to a limit. There is a limit value. Okay, this makes more sense now. I was wrong. I'm a human. I'm not ChatGPT, dude. This function is going to grow quickly, and then it's going to approach a limit value, which makes sense because, well, this is an intuitive introduction to limits. I wouldn't trust an LLM for doing arithmetic. I'm joking. Yeah, that's the canonical example. Like, do not use LLMs to calculate x plus y, or like to count the number of r's in strawberry, etc. I'm just typing into my Mac Spotlight calculator. Let me see. I mean, for what you're doing at the moment, this is perfect. I think it's cool. Like, I think it's really cool. And I'm going to keep going with this structure until I feel like I'm not growing anymore. Like, I feel like I'm getting better. I can feel that and notice that I'm getting better as not just a math presenter, but also as a YouTuber as well. And if we hit a plateau and I'm not growing, then we'll change. We'll do something different. But if your Apple Pencil is cooked enough, it could feel like chalk. Yeah, I have some screen protector thing that makes it feel like paper, and I've been so lazy and I haven't installed it yet. How'd you all justify physically 4 squirrels when time was negative infinity? I don't follow. You mean like predicting 1 year ago there were negative infinity squirrels or something? Do you pick a random time or is there a more efficient way? Do you mean me? What time I stream? Here, you all can work this problem if you're not interested in the banter. If that's what you meant, let me know. An accurate function would probably spit out natural numbers too. Yeah. There should be a floor function in here, and we should teach the floor function in calculus, surprisingly enough. I hope to find some time to read the proof of the implicit function theorem one day. Cool. I just spent like 2 hours deciphering it, but only reading the proof will give me complete mastery. Yeah, dude. Pursue mastery. You can read the proof. You don't have to understand it. You can copy it down on paper, and you will learn something. And then in a few days, you can do it again, and you'll understand it a little bit better. And you'll know what subjects you'll have some clues as to what subjects you should go study more. Oh lol, though I've heard the recent models actually do refer to an actual calculator for numeric problems, but then again, just use a calculator. Yeah, like we don't need to burn any amount of freaking water. I know that they're like closed loop systems and whatever, but like we don't need to improve their metrics of daily usage just to freaking do solar powered calculator calculations. Don't get me on a rant about this, dude. I think Linda should call pest control for her attic. Yeah. Yeah, man. Um, if I were to write a calculus book, I would use the exact same problem, the exact same numbers, the exact same model, but it would be bats. And it would just be like, think about it. How many bats are you going to have in your attic? Take care of them. Like, you have to take care of those bats, dude. Um, there was something else I wanted to check on. All right, nobody cares about the red pen. You all probably don't even notice what I'm talking about. Um, oh, the guitar is muted. Oh, shoot. Thank you. Um, oops. Yeah, that's kind of quirky to just have a video of me playing guitar, but I'm not actually playing guitar. Dude, yeah. It's a live stream. Live streams are hard. AFK for dinner. Yeah, enjoy dinner. The guitar is muted, by the way. Not sure if that's intended, lol. Not a bad idea. Like, usually if I want to turn off the background music, I hide the video. I hide it, but sometimes I should just have it playing, just by the way, I'm a guitar YouTuber. I want you to be able to focus right now on the math, but no, that's funny. Yeah, you're right. Yeah. Okay. I will try to keep it unmuted, but we will try a just sludge content, Subway Surfers, no good reason video of classical guitar sometime. All right. Okay. I was totally wrong. This function approaches it approaches a limit value. So I was going to do something, but now it's basically part C. So let's work part C. How could I do this? One thing that's cool, I think, is even if this is copyrighted, copyrighted PDFs and stuff, and somebody's gonna be like, stop using my content online. I will happily stop, no problem. Please just let me know. But in a classroom, this would be 100% okay. Like, in a classroom, like, of course you could put the book on the projector screen, right? So, like, I think that this would be a sick way to run a classroom that's in like a problem-solving focused kind of Socratic dialogue, discussion-based learning for mathematics. Like, you all did the homework last night, right? Like, let's all talk about it. I noticed the red a bit, but I think it looks fine. Okay, cool. Now that I pointed it out, yeah, it just looks like a little weirdly pixelated compared to all the other colors, but I don't think there's anything I can do about that. I have one idea, but there's no way I would bother. All right. Okay. Nope, not duplicate. Dang it. Is there a clear? Yeah, there is a clear. Okay, great. Okay, so approximate limit of S of t with a table of values. Can I duplicate this freaking thing? Which one is it? All these, is it this one? What the hell? This? Yeah, okay. There we go. Let's duplicate this thing. Now we're working part C. What can you do with technology that you can't do on a chalkboard? Like, that's kind of a thought that I have. That's, like, I want to explore and practice and see what can we do here that you just cannot do at all on a chalkboard. Like, this kind of stuff is fun to me. Like, I'm learning every day some new ideas of how I can use the iPad. All right, so we already have a table of values with these values. 0 for 16.86, 19, 16.86, 19, and 21.43. Okay, so let's freaking add a 0. It's a really good strategy, everybody. If you want to try to get better or like go harder and try to do something better or like just push yourself, just add a 0 to whatever you're trying to do. Like just you want to finish that homework set in 30 days. All right, what if you had to finish it in 3 days? Like what would you have to do? Or more realistically, like something like I want to get 100 subscribers in a month. What would I need to do if I wanted 1,000 subscribers in a month? Like it's a great thought exercise. And y'all could look up a talk by Brian Chesky, CEO of Airbnb, if you want to learn more about that idea. Okay, so I'm going to add a 0 to that input value. It's not just going to add a 0 to the output value. As we predicted, this function is actually going to now keep slowing down and approach a number. So 12 plus 5.5t divided by 3 plus 0.25t is f of t, or s of t. Why s? Oh, squirrels? Okay, yeah. So I'm just going to ask my simple solar-powered calculator. 12 plus 5.5 times 3650 divided by 3 plus 0.25 times 3650. Yeah, 21. It's approximately 21.94. And, well, again, if the number of squirrels actually would be 21 and 21, and, you know, maybe one is cooking, like, we're 94% of the way through the next squirrel. And what about if we added another freaking 0 to that? All I have to do is just type another 0 into my solar-powered calculator, and we get 21.99. Are we ever going to get that 20-second squirrel? Let's add another 0. Nope. Hell yeah. 21.999. I'm going to add 3 more zeros. Yep. 3, 6, 5, 0, 0, 0, 0, 0, 0, and we get 21.999. How many nines? 199, 999. That last squirrel is just not gonna happen. Okay. So as I predicted, the function is going to look something like this. And now I can see that this dotted line, this horizontal asymptote, is 22. start at 4. This thing is going to go up to 22. And the graph looks something like this. Not exactly to scale, but you know. Let's answer a couple questions. Turn off anti-aliasing so all colors look equally pixelated. Bad idea. Bad idea. They should make a giant iPad chalkboard so you can do all this in the classroom. I think I could do exactly this if I wanted to in the classroom. Every single thing about this stream I could. I just need a TV. I literally just need a TV, and I think, unfortunately, all of our classrooms have TVs now in them, right? Hey, JC, I'm having such a hard time learning. I guess I need TV and Wi-Fi, and, like, reliable Wi-Fi. Hey, JC, I'm having such a hard time learning vectors and 3D algebra. Dang, dude. Okay. Neuralized. I'm going to create a brand new Discord channel for you right now. How about that? Bro, I want to help you out, okay? Neuralize says, help with vectors and 3D algebra. My response is going to be discord.jcpractices.com. You can also get to it from the description in the video, but that's boring. I want to write it, you know, big, bold, yellow letters here on the iPad. There's going to be a brand new channel in like about 1 minute called Math Help. Okay? If nobody else gets to your question, then I'll get to it eventually. How about that? Here you go, dude. I'm going to try to help you out right now. Doesn't take very long. Are you in it already? And what's your username? If you are, dude, are you already in it? All the new math people who've joined are fairly quiet. Most people are quiet. Okay, hell yeah, dude. Oh wait, I'll be in it. Yeah, man, dude. So there's now 3 math channels. There's #math, broad, general, any math topics. If people want to share a problem you're working on, I think that's the best place. But if you have a question, if you're stuck on a problem, or if you want help, I feel like that's a good, clear name for this. Like, if you want help on a problem, go to Math Help. I could help, but hopefully other people could also help if other people want to as well. Like Arad looks like Arad is ready to help out. He said, what kind of stuff are you working toward? Yeah, you got to be more specific than just an exam. Like, man, like differential geometry? Are you studying differential geometry? There's a lot of 3D imagination there, or like topology or something. Are you studying like knot theory, dude? Or, you know, are you learning to plot like a plane or vectors in 3D space for the first time? Like, if you could drop like a specific problem in that channel, I think we'd be happy to help. Let's see. Remember me saying I would tune your guitar to that weird tuning. Why? Are you actually about to release a single? Nice. That's great. Okay. Okay. You're gonna get me on a tangent again. You're on the blackboard twice today, dude. This might be a new record. I don't know if somebody's gotten on the blackboard twice in one stream. This isn't available yet. Right now, if you type this into your browser, it's just going to go to my link tree. By the way, I have a link tree. You could also just go to jcpractices.com for that. But soon, very soon, just Google this. Hyperbole and half a lot. Today's your lucky day. You're like one of today's 10,000 lucky people who are seeing this amazing, brilliant, hilarious article from the early internet, from back in my day when I was, I don't know, a teenager or in college. I don't remember when this came out, but today's your lucky day. I hope you check this out. Oh, I can link. I can just link to it in the chat. Here you go. Here you go, dude. I don't mind if you go and leave the stream. Please leave the stream, everybody. If you don't know what I'm talking about right now. Where did it go? If you don't know what I'm talking about, which I get it, I'm an old person. This is from 2010. Look at that. I was in college. Today's your lucky day. I also just pasted it in the Discord general channel. I'm not making fun of you, dude. It's a very common mistake. But a lot is actually 2 words. And this is also, for a lot of people, I don't remember, it's like a English as a second language thing, but this article is the funniest article about the Allot, a mythical, magical creature named the Allot. And I don't want to spoil it, but yeah, I hope you enjoy it. Yeah, I had no note mapping whatsoever, but something really came up, and I'm looking for it. Wow, you're actually composing a song in that really, really weird tuning. Have you heard me playing Mysterious Habitats yet? That one is in a weird tuning. It has the 6th string tuned up to F. Great piece, man. Great. One of my favorites. Oh, you've heard it. Great. Cool, man. All right, let's keep going. So, approximate... verify there's 4 squirrels done. Calculate how many squirrels are coming up soon. Approximate with a table of values. What does this mean in real world terms? That at most 22. That this is some sort of steady state population. Okay. I think I answered that a little farther than a lot of people would in this. Oh man, is the iPad not updating? So annoying. Okay, so at most 22. In the real world, if there's not enough food, that's going to be a limiting factor. There could also be predators. Right? There might be predators of the squirrels in your attic, but there's like a rate of birth. There's only so much food that can sustain these squirrels in the attic. There's only so much physical space in the attic. Maybe there's predators of the squirrels in the attic. I don't know, dude. But like for some reason, that population will not ever cross 22, according to this model. Right? Okay. If you could give me an advice related to integration, what would it be? Because I'm kind of cooked in integration. I'm sorry. Unfortunately, it's going to be a while. But you got a couple options. Harsh. This is the same. First answer is the same as neuralized. If you want help on some math problem, you could join the Discord and you could join the math help channel. And you could ask your question there. And if somebody wants to help you out with integration, one of us could try to help. Alternatively, thank you for your consideration. You could pay me, dude. $20. I will pause and I will stop this practice stream right now, and I will tutor you in integration if you want. I will do anything for money, y'all. Like if anybody wants tutoring, I'm available. jcpractices. I will study any math, tutor any kind of math. I'll do my best. I may or may not be able to help, but I'll try my best. And I think I could help with integration. Yeah, man. Oops. So thanks for your consideration. I know that $20 USD is a lot of money around the world, but in the US, that's like just barely above minimum wage. So, I can't solve exchange rates, unfortunately, but I am looking for the tutoring experience. So if anybody wants tutoring, just hit up your boy. Okay, let's keep going. Where are we? Oh, yeah. Last one. Graph with a graphing utility and use the graph to verify your answer to part C. Nah. I don't feel like it. It's gonna look just like this. It's gonna look pretty close to this, I think. If somebody else wants to do it, and you can use Wolfram Alpha, and let me know if I'm totally wrong, but Wolfram Alpha is a great online free graphing calculator. Someday I'll get one of the fancy new expensive Texas Instrument calculators, but I haven't needed a graphing calculator literally since high school. I'm a mathematics major. I studied pure mathematics, and I never once needed a graphing calculator. But the new ones look really nice, so I do want to get one of the new ones now that I'm teaching high school math. So let's keep going. Formal definition of a limit. Slowly but surely we're going to get here. What's the smartest way to do this? I know. I got it. Let's get rid of all this other stuff. Oh, new page. I think I would erase. Okay, I'm getting a little sniped here. Okay, there we go. Cool. All right. Oh no, it wouldn't erase the image if with your eraser. Whatever. Formal definition of a limit. Yesterday we were talking about the epsilon delta definition of a limit. Taalman calls these delta epsilon definition and delta epsilon proofs. This is an optional section. Trust me, bro. I'm going somewhere here. This is an optional section that goes into this topic more deeply, like using proofs and going a little bit deeper. But she does say that learning the epsilon delta definition is important for everybody learning calculus. It's so important that it's section 2, and that's awesome. I feel most high school calculus books would make this an optional section. Like the formal definition of a limit is optional. It's not. It really is important, or it shouldn't be optional. But here's the crazy thing, dude. Like, she calls them delta epsilon definitions, and that's rage bait. This is literally rage bait. I'm a YouTuber, so I'm very familiar with rage bait. You need something to get attention as a YouTuber. You need, like, a common strategy is rage bait, and you say something incendiary in your title to get people to click. You get people to be curious, like create a curiosity gap. That's what some YouTubers will describe, like when you ask a question and it's unresolved. Oh, dude, Arad, that might be it, man. That might be it. You might be right. Which would make me very happy in some ways and also make me laugh if so. How far do I want to go down that train of thought? Delta epsilon is just super non-standard. Everybody in the world, every other book that you read is going to call this an epsilon delta definition. I mean, maybe it's just because I'm used to it. But that sounds better. It rolls off the tongue better for me, but that's because like every single other book I've ever read has always called it epsilon delta. But I think that the argument for me on this is that delta depends on epsilon. You pick epsilon and then you get delta. Like, yeah, delta depends on epsilon. Like, you pick a delta from the epsilon. So epsilon is first. Like, epsilon is first in the definition. In, like, hieroglyphics, we write this definition of a limit. Like, for all epsilon, there exists a delta such that blah, blah, blah. Like, in hieroglyphics, epsilon comes first. And it's important. You can't swap the order of those two. So it's wild to me that she calls them delta epsilon, and I haven't read the section yet at all. So there's probably a reasoning. Like, so far this book is fantastic. I've enjoyed it so far. And the text is very conversational. There's moments where she says, like, stop and have some tea and keep rereading this, have some tea, and don't move on until you understand this, because it's very important, which is just super cool. Like, it's very conversational, but also very organized. I like it a lot, and I'm not even sponsored. I don't even have an Amazon affiliate link because I'm too lazy, and at my YouTube size, I'd just make like a penny. But if anybody wants to buy this book, let me know first, and I'll set up that link, and then I'll earn 1 penny, and then maybe in the future, other people will buy the book, and I'll make $1. But yeah, like, I'm just saying, I'm a big fan so far of this book because it's very different than the others, and this might be Taalman's clickbait. Like, this is the clickbait. Like, curiosity gap. Like, why in the world would she call them delta epsilon? Like, no good reason, just to get you to click. Like, did you click? Did you look into it? By the way, I'm teaching delta epsilon in section 2. like that's, I think that this is rage bait. I think that this is actually just rage bait, which is awesome if so. Arad said a really good point. It is alphabetical. Is that why? If so, I get it. I completely get it. In software, I alphabetize every single thing I can, and then that has infected the rest of my life. When I get an opportunity to, and I have to decide on some kind of order, I alphabetize. Unless there's a very strong reason, I default to alphabetizing everything. It simplifies your life. You can just move on. Like my phone screen, when I used to use icons for all my apps on my phone home screen, every single app was just alphabetized. Maybe different categories were on different pages, but for the most part, just alphabetized. And it simplifies your life so much. But this, to me, would qualify as a good reason not to alphabetize. You know? If anybody can think of a good reason here, no, maybe alphabetizing apps is too far. For some people it is. I've always recognized that, and I've always been like, LOL, I alphabetize my apps on my phone. I love it. It's like your computer alphabetizes your apps in your Finder, in your like file explorer. Why not on your phone? Why not on your home screen? But I get it. Like, yeah, maybe that's rage bait for some people. To me, I just don't yet understand. I can't even... I don't even have a joking reason why delta epsilon, you know, other than, I guess, alphabetization. No, I haven't tried JEE yet. I'd like to someday, but for now we're focused on calculus. I teach high school math with calculus, like United States high school math with calculus, undergraduate math with linear algebra, and graduate level math with representation theory. Yeah. People ask for JEE problems a lot, wonder why. I think because of the time of day, I attract United States graduate students who have some free time and they're procrastinating their thesis. I attract some unemployed musicians, self-included, and then I attract musicians and mathematicians from India, because right now in India it's like 6 p.m. What time is it over there, dude? Yeah, like it's kind of like the after school time, like a really good hangout on YouTube time. It's the work day for me. It's like the middle of the day. Like I want to hang out with my wife in the evenings. I don't want to be on YouTube in the evenings. So I think it's the time of day, and then therefore YouTube is like, yo, dude, like let's show this to more people based in India. And you know, that makes sense. Like I think that right now the algorithm is somehow tuned to people looking for the JEE. I think people are searching for JEE, and then they find this channel, and then they keep hanging out, and you know, it's a virtuous feedback loop. I think 5 years of teaching experience, asterisk on stream. Yeah, like technically, yeah. But I've been teaching. I've been group teaching. I've been teaching in front of a group to an international audience with averaging 10 students from an international audience for 1 year. Grad students with free time procrastinating. I feel called out. You should get back to work. All right, let's keep going. No, I'm glad that you're procrastinating with me. I'm procrastinating, getting a job. So, formal definition of the limit. Write each limit in these exercises. Let's ignore this one for now. As a formal statement involving delta, epsilon, n, and or m, and sketch a graph that illustrates the roles of these constants. Dude, this is such a cool book, man. Like, this is such a cool book. In the last 6 exercises, you may take f to be any appropriate graph. Okay, so that part doesn't apply. Let's just take that out. Let's take this part out for now. Don't worry about that stuff. Okay, in this problem, we're not going to need n. We're not going to need m. We're just going to need these other parts. Let's see. Okay, this is just stupid now. Like, not needed. That's unnecessary. But, solution. Let's get a solution. Totally unnecessary. Solution. Recall the definition of a limit. I'm going to try to copy this again from memory this time and see how close we get. Let's use a secondary accent color. Definition of a limit. Let's see how close I get from memory. And this, I think, is good practice. Like good deliberate practice. Hey, take care, Ta. Thanks for stopping by. Yeah, I've been teaching representation theory for about 2 months on YouTube to an international audience, including PhD students. That's true. That is actually true. I'm teaching PhD students representation theory, and it's a very serious stream. Okay, so the limit L of a function f, it doesn't need to be from the real numbers to the real numbers, but this whole book, I believe, is assuming reals to reals. But now that's also restricting our domain. So if I were formal, I'd do some sort of subset of the real numbers into the real numbers. But let's just omit that. Let's just hand wave here. Let's just say of a function f of x, of a real valued function f of x, is a real number such that for all epsilon greater than 0, epsilon is a real number. There exists a delta greater than 0 such that when the x values x minus, oh wait, no, sorry. The limit L of a function f at a point C, at a point, the limit L of a function f at a number C at a at a point, is that the right phrasing? I don't remember, man. Is such that when x is close to c, then or something, I could say implies, or a forward arrow, that the function value is close to your limit value. How close was I? I know that I used different terminology, and I wrote this slightly differently than Taalman, and that was intentional. Because I also wanted, in the process of this, to show you all how another equivalent, what does L, lunate epsilon, blackboard R mean? Okay, see, this is pedagogy. Like, Chris, this would help me as a teacher. How do you like this definition compared to this other definition? Like, this is a serious, real, serious talk question for you. Here is the definition, which is equivalent in Taalman's book. Let's use red. It's Taalman's book. It's going to be slightly more precise. It's not going to, like, I forgot to write at a point C or something. You know, there's going to be slight different verbiage, but there's a core structural difference on how it's presented. But these are two different equivalent ways of writing the same thing. And this is going to help me as a teacher know which way to teach for the future. You know, I'm going to write this down and you're going to vote for my definition or her definition. I could set up a poll, but let's go. Definition, limit. The limit I would have also said we write this as limit as x tends to c of f of x equals L. Like, this would have been like my concluding sentence. If I thought about it for a second longer. The limit f the limit lim x, the limit, I want to say the limit near c of the function is L. But this set of symbols means that for all epsilon greater than 0, there exists delta greater than 0 such that if x is in this interval, neither of these is going to feel intuitive. Neither of these is going to immediately jump out at you as like, Oh, that one's like a eureka, and then the other one is hieroglyphics. Like, both of these take a moment to understand. They take some time, like literally make some tea and think about it. And most importantly to me, draw these pictures for yourself. Or watch my video from yesterday. This is the limit in a picture. And it helps a lot, I think. If you can draw this picture for yourself and reconstruct it for yourself. And then understand that if you can shrink, like literally physically shrink on an iPad, epsilon into a smaller interval, then you have to shrink your delta interval as well. But you can, no matter how much you shrink that yellow band, the blue, like I'm going to call them neighborhoods. No matter how much you shrink that yellow neighborhood, there is another blue neighborhood that keeps this box like entirely contained within, like every function value is within your level of accuracy. I like to use the word accuracy for this. Like, epsilon is the accuracy level that you care about. Like 1 decimal place. Like, I'm an engineer and we always round to 2 decimal places or something. You know, but I'm a physicist and we care about 10 decimal places or whatever, right? Like, no matter how accurate you demand your function to be, when you claim that the function value is close to that point, to that value, then you can always find a close enough neighborhood of around your limit point C, so that the y values the function values are always close to your limit value. Depends on the context. As an introduction to students, the first definition is not great. The second one is a bit less understandable than the first one, to me at least. Okay, so you said that neither of them are good, if I understand correctly. Happy Abe says, I like difference notation over interval notation. More like 0, absolute value, x minus c, less than delta. Yeah, I think you're right. Am I missing? Does that require... I mean, do you need 0 less than x minus c? Do you need this part? It's been 15 years, man. Like, throw me a bone here. I don't, do you need that? Yeah. Oh, yes, you do, don't you? Because you do. Oh, thank you. Yeah, you're absolutely right. You need x to be different than c. Yes, you're right. And we can construct an example for ourselves. Again, my favorite example are always these lines with a hole. And we can fill in that hole somewhere else. But we still say that the limit of this function is L, not this other point. Yeah, you're right. Thank you. You're totally right. I'm missing that. That is important. Okay. Oopsie daisy. Thank you. I just got some free tutoring. Look at that. Thank you. Yeah, that's important. That is important. This does take some time, and you can make a mistake like I just did. The punctured interval notation, the way that Taalman writes this way makes sure that you remember that x is not equal to c. X is close to c, but it's not equal to c. Like Taalman forces you to really remember that. But it just looks aesthetically less pretty to me. Like seriously, there are forms of this, the slightly more hieroglyphic version of this, I've considered getting tattooed. It's just such a pretty, nice little definition once you've internalized it. But it's hard. You have to drink a lot of tea until you can really work with this and get it. And you don't need it to pass the AP calculus exam, but let's take a moment just to appreciate something really nice. Oh, yeah, you're right. X over X is even more simple. That's closer to what I just drew right now. I just thought that. I was my first instinct was, oh, I'm going to draw a line like this. But you're right. This is X squared over X. Whereas this is X over X. Thank you, bro. You're absolutely right that this is even simpler. So this is the value 1. And then here, I'm just going to say that this number is 2. Right? Yeah, absolutely. You're totally right. Thank you. Why is there a point there? I made it up because I want it to be there, literally. So f of x equals x over x is undefined at x equal 0, right? But we can fix it. So what I'm doing over here is defining a new version of that function. 2 or 0 or whatever you want to pick. I guess I could go even simpler. 0 divided by x. And then define the one special point. Something else. But let's just keep going. So I'm going to say it's x over x when it's allowed to be x over x. But then for that one special value at x equals 0, I can define it to be whatever I want. It could be a huge number. It could be a billion. And then we get the epsilon delta argument says that everywhere close but not equal to x equals 0, everywhere close to that, the function value, everywhere close to that point, the function value is 1. Right? But at that point, it's allowed to be anything it wants to be. Bob the Builder style. Exactly, dude. If you want to know more about that, I streamed a classical guitar concert yesterday dedicated in tribute to Bob the Builder. So if you want to hear some classical guitar while I rant about Bob the Builder, that happened yesterday. And that's why I'm a little inspired. Can we fix it? Yes, we can, dude. Yes, we can. Can we build it? Yes, we can. Okay, so all of this is like a little lecture to remind ourselves about the definition of the limit. I tried to do a practice repetition. I tried to do some spaced repetition practice, trying to reconstruct this definition of the limit from memory. And I got close, but I made a mistake. I'm going to remember that mistake in this red letters. And I'm not going to beat myself up about the fact that I made a mistake. I'm going to enjoy that fact, because now, next time that I try to rewrite this from memory, I might not make that mistake. I'm less likely to make that mistake. So I'm very passionate about this idea of like, try to write down the definition from memory, then look at the book and keep coming back until you can write it from memory. Okay. I keep recopying this problem because now we have a definition that we can work with and we can complete this exercise. Write this limit as a formal statement I would like to be able to copy this problem without copying the whole thing. The solution to this, we are going to have, for one second. Oh, Bob the Builder. I need to be able to quickly put Bob the Builder on screen because Bob is like now my new mascot, I think. Like at least for a few days. I'm just feeling like please help me, Bob the Builder. Challenge, explain all this for someone who doesn't know math. That's what I'm trying to do, man. Please let me know how I'm doing because I want to be able to explain difficult math to somebody who doesn't know math. That's kind of my goal. That's actually kind of my goal. Nice to meet you, F9. What's your deal? What's your deal? What's your story? Do you like math? Are you a math person? Do you hate math? Okay, so for all epsilon greater than 0, there exists a delta greater than 0. Such that if x is in the interval from -3 minus delta to -3 union -3 to -3 plus delta, then the square root of x plus 7 is in the interval 2 minus epsilon to 2 plus epsilon. Yeah. I think I got it this time, right? You like math. Okay, cool. Have you learned the epsilon delta definition of limits? We're talking about calculus today. Ooh, yeah, we should probably intersect with the domain of square root of x plus 7. You know, you're right. Because epsilon can be... Yeah, I mean, you're right, but I've never seen that. That is a level of pedantry that I haven't seen before. I mean, and it's not included in Taalman's... I kind of like that. Wait. No, do you need it? Let's see. Oh, yeah. Because, well, wait. I was going to say, yeah, you got great question. I'm going to call it a question at least. Happy Abe said we should probably... Do we? This is an actual question to you all. We should probably also intersect with the domain of F. If we were pedantic about it, do we? I'm not reading chat. You may have answered this already, but I'm trying to think out loud and trying to construct why that would be true. Let's see. Square root of x. This is an example. This is one of the first examples that came to my mind of a function that is not defined for all real numbers. As a real valued function, it looks something like this. The square root of 1 is 1. The square root of 4 is 2, right? And it keeps growing more slowly. The square root of 9 is 3. The limit as x approaches 0 of the square root of x, we want it to be 0, right? Because it's going to approach the point 0. Right? So, do we need to fix the definition and say x, anytime that x is in c minus delta to c union c plus delta, right? Then... Do we need to fix this definition because 0 minus delta, like we can't take f of negative point anything, any 0, 1, right? That's a small negative number. We can't find any delta that would extend this neighborhood around 0. Because if I pick x values that are close to the left, I don't know if you all can see that little red dot. This is an interval around 0. But negative 0.1 is not in the domain of f, so I can't say that this is in the interval of 0 minus epsilon to 0 plus epsilon, right? This is a great question. I really like this question right now and this opportunity to think out loud. And you all might be screaming at your television sets at the moment with the answer, which would be really awesome if so. We don't need the fix that you're proposing here, in this case, you're proposing that we need to also intersect with the domain of f, because now we take a very small negative, like the left neighborhood of 0 is undefined for the square root of x, right? But I don't think we need it yet. We might need that in some later definitions or something, or some other cases, because this is wrong. This is not true. This is actually not true. The limit from the right of the square root of x as x approaches 0 is 0. But the limit as x approaches 0 of the square root of x does not exist. Right? So I'm stalling for a second here to also think of another example where we do need to intersect with the domain, but I believe that for the function to have a limit value, you always need some left and right interval. Like, we need some level of continuity around that point, right? Is that right? Man, my analysis, I'm not great at analysis. My preference was always algebra. So I feel like I'm missing some of these weird counterexamples that you all have. All right, so I'm going to read the chat now and see if there is another case that I'm forgetting. So the limit from the... Oh, I said from the left. My bad. From the right. That's what I meant to say, obviously. The limit from the right is 0. But the limit as x approaches 0 does not exist. And right now, we are only defining the two-sided limit in this definition. I think later in the section, we define the one-sided limits. In which case, you just rewrite these intervals and you just lose one of the sides of the interval. All right, so I'm going to read now. Oh, cool, you're in Algebra 2. Nice, dude, nice. And you are learning a tiny bit of calculus, even if the only thing you get out of this talk today is the fact that we're talking about some weird ideas of smoothness, or functions that are getting close to a value or something. Just if the only thing that you learn today is the fact that there's some weird, cool, pretty math statement or confusing math statement that uses these funny looking letters, epsilon and delta, and that this is important for calculus, but not everybody learns it, then you learned something today. And I can teach that to somebody in Algebra 2, I think. I can teach that level. You can understand just the fact that you're going to learn this in the future, and some people hate it, some people love it. Okay, if we really want to be pedantic, we should probably intersect with the domain of square root of x plus 7. X plus 7, what? For example, if delta is big enough, then the square root won't even be defined. Hell yeah, I picked the same example you were thinking of, right? I picked the same exact example you were thinking of. but you pick epsilon, not delta, right? Oh well, I'm late again, bro. Yeah, it happens. Like, say you start with a huge epsilon, then you might think a big delta would work, but we also want delta small enough so that we stay in the domain. We can always find such a delta that will stay in the domain anyway, so not technically needed, but the delta you find should be small enough so that it holds. I think I handled the exact same. I thought you were right for a second too. I was like, oh shoot, there's something we're missing that Taalman also missed that they write in like later calculus books. But no, I don't think you need it. I don't think you need it, dude. That's not correct. The limit of square root of x exists as 0 since it's only defined on the right side. I gotcha there. I got you with the rage bait there. The left and right only need to agree when defined there. Same, I suck at some analysis. Me too, man. Hi, John. What's good? Limit from the right. Yeah, that's what I meant. You know what I meant. Got him. How useful are one-sided limits? It's been eons, and I've forgotten most of it. Me too, man. I hope that I can see more applications or ideas involving one-sided limits in this book. I remember them being taught in AP Calculus, and I learned them and I got used to them. I don't know. I mean, I think it's like we want to be able to say that the limit of square root of x is 0 near 0. So we need to like have this like precise, well, actually, there's something called the one-sided limit. Like, yeah, I think that this is just a really good example. You came up with the exact same example I was thinking of too. I picked a simpler one. I picked a better one than a grad student, so hell yeah, dude. But, yeah. So you need to intersect with the domain when it's only defined on one side, like in square root of x at 0. No, I don't think so. I think you, on the one-sided limit, here, I haven't read the definition of this yet, but I think that we define the one-sided limit as for all epsilon greater than 0, there exists a delta greater than 0 such that if x I could be wrong, man. Like I'm really thinking out loud with you right now in real time, so I might be missing something. But if x is not equal to c, here's the thing. In the interval notation, or in this more hieroglyphic form with the absolute value, I think you might need to add it. I think you might need to add it there, but you don't need it in Taalman's interval notation, I think. So that if x is in c to c plus delta, that this implies that f of x is in L minus epsilon, L plus epsilon. Right? Like, you fix the domain issue right here. That this is the definition of the one-sided limit from the right. I'm just using that example again for the square root of 2, or square root function. Right? The example I said is the one from this problem law. Square root of x plus 7 is this problem. Yeah, well, we're both... Oh, that's why you picked... Oh, it is. Oh, was that the problem? Yeah, oh, I see. Great. Okay, for all epsilon greater than 0, there exists a... Okay, I see what you're saying. You're right. I see it now. I do see it now. Ah, got it. You're right. I gotcha. Yep, you're totally right. Because I went to this example, which is only defined on one side. Wait. Shoot. Analysis is hard to me, man. Like, okay, so if epsilon is huge, no, man, like, no. You don't need it for that one. I don't think. Because, like, I can take epsilon to be enormous, right? Like, I think that's what you're proposing. We pick an enormous epsilon, 100. Oh, yeah. Then, well, wait. If epsilon is 100, we can still choose delta equal tiny, right? Like, you're allowed to pick any delta you want. So we can still say that for all epsilon there is a tiny delta close to whatever your limit point is, right? That we're like considering. I'm literally trying to think on my own about this and think out loud and try to give some of my problem solving steps on how I think about debugging a problem like this in math. Right? Like, I don't think that you need to... I don't think you need to change this. But we got another legit mathematician in the chat. What's up, Leo Lectures? I'm going to read chat in a second. What am I missing? I'm saying the limit exists for square root, not just one-sided. You're right. I got that eventually. Bob has 5 billion hammers. He did 20 limit questions. How many buildings can he build now? I love that. I mean, we generally take a very small delta, but we take an epsilon. This is key. This is big right now, I think. In my understanding or teaching, a theoretical classroom in the future, we could have this discussion-based learning where somebody suggested, like, well, what about this? Like, don't we need to guarantee that? Don't we also need to intersect with the domain of F? And you still might be right. I might be missing it. But the book doesn't include that. And I wonder if it is a pedantic thing that, like, more advanced math books will include. I don't see it yet. I don't see why yet. There's wiggle room at x equals 2. Yeah, you should think about it. Yeah, you should think about these things, and that's excellent that you brought it up. Like, I'm pretending I'm in front of a classroom of, smart kids, and trying to teach the limit for the first time, and I'm getting some practice around that. When f is square root of x, and we want to evaluate at 0, then no small delta will work at 0. Right, since 0 delta will always be outside the domain. Well, that's exactly the point. That's exactly the example I was constructing. You're saying the same thing that I was in this simpler example to me. The this limit is not defined. Like, we cannot define the limit. Like, the definition fails for the exact reason that you're bringing up. And this is probably an example in the book, like in the set of exercises, which is super cool. Like, I'm very curious. I want to look into the set of exercises. I bet that this example is in here. It's a great example. Like, square root of x, the limit as x approaches 0 does not exist. It does exist for the one-sided limit, right? Oh, I said Leo, but I meant Levi. What's up, Levi? I apologize. We have two blue mods, Leo and Levi, and your names are also a similar length too, so I apologize, Levi. I don't know, man. I'm gonna keep thinking on this, but I think I don't think we need the intersection of domain in, at least in the interval notation. I mean, I think in either case, I don't think we need it, because we need... Like, I'm trying to imagine some sort of, like, weird, super weird topological, whatever, imaginary functions, like something that's only defined on the irrational numbers near a point. Like, I'm trying to imagine weirder examples at the moment. Like, I don't know, and you grad students would know this better than me. Like, what about a function like this? 0 and 1. If we use the simplest numbers, our function is either 0 or 1. It's 0 almost everywhere. No. Yeah, I like the way that it would look if I do it this way. No. Sorry, this is unimportant. Like, the presentation here is what I'm thinking of. So f of x is 1 and 0. It's 1 for rational numbers. Okay? And it is 0 for the irrational numbers. So I'm trying to come up with, like, a weirder example in, like, more pedantic, higher level math where we would need to add that extra modification that in a calculus class you're not that pedantic about. So, like, don't get me wrong, I'm, like, giving you credit here, or, like, believing that I might be wrong and that there are cases where we do need to add the intersection of the domain. But, like, if so, then why doesn't Taalman include it in this book? I think I don't know. Like, that didn't come out as clear as I wanted it to. But what I'm trying to get at is that, do we say that the limit as x approaches anything, 0, of f, do we say that this is 0? Like, dude, grad students, help me. For those who are maybe seeing a weird example like this for the first time. This function is 0. It's 0 for all the irrational numbers. And guess what? This is a super cool fact, but like, even though you can imagine that there are infinitely many rational numbers, even though there are infinitely many rational numbers, the number of irrational numbers is infinitely less than the number of real numbers, of irrational. There are infinitely many more real numbers than there are rational numbers. So, do we refer to... I mean, I think that we would just say that there's not, because you can always pick... Yeah, this is not a good example. This doesn't work. The limit as x approaches 0 is undefined, right? This does not exist, even though there are uncountably many more values of f of x that equals 0 in any neighborhood around the point 0. But you can always find a counterexample to the claim that you can, for any delta, there is an x in any neighborhood around the point 0, just to keep things simple, but that could be any point or any c value. For all delta, what I'm trying to get at here is that there exists, we can find one such that f of x is equal to 1. Because the rational numbers, between any two numbers, you can find a rational number, an infinite number of rational numbers. The rational numbers, we call it dense. We're getting like into some cooler math right now, but there exists a rational number that is also in this interval, right? I don't know what JC is trying to do. I'm sorry, I've lost you all. This makes sense to me, but it was a comment earlier from Happy Abe that said, yeah, Happy Abe. This is exactly what I was. Yeah, I got there. I got there that this does not exist. This limit does not exist. Here's an example of something else that I thought, even though there are infinitely many more points in any interval that equal 0, the limit does not exist. And this is I decided to keep going with this explanation to give a cool example in this little teaching sample of how we can use these definitions and construct like an interesting counterexample. But right now I can't think of a counterexample that requires you to say that x is in, where you have to specify that x is also in the domain of f. I don't yet see it. But the rationals is dense. Hey, take care, Agent. Good to see you, bro. There's another definition using sequences of points approaching C where those points come from the domain. Okay, yes, I believe in definitely vaguely remember that too. In I think any or most analysis classes, you focus on the limit of a sequence before you focus on the limit of a function, of a continuous function. And that's, yeah, like most of my class was talking about sequences instead of functions. And then you define limits first for a sequence. When I tried this stream like a year ago, I showed how an analysis book started there, and I showed the definition of a limit in different books. I think I showed it maybe like Taalman's intuitive definition, then Taalman's formal, then an analysis book, which starts with sequences, and then a topology, like, like the topology definition. The definition of a one-sided limit implicitly requires that the domain of F intersects the punctured right neighborhood for all sufficiently small delta. Right, like it already is implicitly there. I don't think we need to explicitly state that, right? I think Levi is on my side here. The regular limit also requires that when it may only be defined on side, like, well, no, the regular limit does not exist, right? Levi, like, so we are talking about the exact same example, and I wonder if this is like just a difference in definitions and terminology, because that is what math is, and lots of people don't realize that, but math is all a logical game where we have to agree on the same definitions, and I wonder if there's a definition difference in how you're seeing this versus me. Not sure if I follow. Wait, what? The irrationals don't have the same cardinality as the reals? What? Might want to look at more advanced books for that more pedantic definition. It's possible Taalman is just trying to make sense for undergrads. Please, yes, I would love to. Give me a name of a book that you think would have it, and I'm going to come back next time we do calculus and try to show that. Because I did something like that in the past. Why don't I just try right now? Like, I've done this before, but I'll do it now. I'm excited. Don't get me wrong. I'm not like trying to argue with you. I'm like excited about this because I love this kind of thing. Like, like I totally believe you that a more advanced upper division analysis course would also include that, and Taalman might just be drawing the line at this point. Like, I would love to see if, like, here's a place where Taalman is hiding analysis from this calculus book. Like, because there are weird examples in analysis and topology where you do need to specify that, but we hide, we simplify the world for the freshmen, right? This is the book that my year-long analysis, grad level analysis class, first semester was taught out of Rosenlicht, and then second semester was taught out of Spivak, Calculus on Manifolds. Limit of a do we need it if you define the limit of a function in terms of the limit of a sequence? You wouldn't, because you don't need to define the domain of a sequence, right? So that wouldn't be true. Limit of 72. Good Lord. Okay, man. I thought that we would also have... Is there not, like, a more straightforward... I thought that we would have a real valued definition of a limit. Okay, now this book is... Okay, so I took 3 analysis classes. One was an intro to analysis for undergrads, and then I took the year-long sequence that was for undergrads and grad students. Like, I think half the class were undergrads, half the class were grad students. So this was from the grad level class. I'll write out this definition too in a second. Do I have my undergrad book? No, I don't. I think it's at my parents'. Yeah. Right. Okay. So open sets. Yeah, like if we're talking about open sets, like the topological definition, things might be different. I do believe you, but when we're defining on real numbers and real valued functions, I don't think we need it. I don't think we need to add pedantry to Taalman's definition. And the reason that I care about this right now and that I'm drilling into this is that it's like exactly the theme of this topic, of this section of like, let's take the intuitive definition and make it more rigorous and make it more formal. And in math, like, you're not done. This isn't the final boss. This isn't the final form of the limit. For anybody who's learning this for the first time, guess what? It gets scarier, dude. And it's beautiful. If you drink enough tea, it's actually quite beautiful. So I'm going to write out definition according to Rosenlicht. Let me check Spivak, actually. I know that you said that Rudin does this, but yeah, I know. I don't have Rudin. What about Spivak? Is there an index? Yes. Index. Limit, page 11. You're right. I mean, Spivak does say in the domain of F. So Spivak is friendlier, actually, than Rosenlicht. Yeah, which is cool. I mean, it's a lot scarier in other ways, but it's closer to what Taalman wrote. And the standard real value definition of a limit. You're absolutely right. I just don't yet have the counterexample that requires this. And I look forward to learning it. So let's see. He's Spivak. writes in the baby, or not baby, like tiny Spivak, which is the scarier Spivak. Spivak also has an like intro to analysis book, which is called Calculus, but it's really intro to analysis, and then this is like a second course in analysis or something. Spivak, Calculus on Manifolds. This dude writes, I'll say it out loud. The notation lim of x tending to a of f of x equals b means, I'm going to paraphrase intuitively. The notation means, as in the one variable case, that we can get f of x as close to b as desired by choosing x sufficiently close to, but not equal to, a. In mathematical terms, this means for every number epsilon greater than 0, there is a number delta greater than 0 such that absolute value of f of x minus b is less than epsilon for all x in the domain of f, which okay, so here we go. This book is white, so why don't we just stay with white accents? You're right. So I just still don't see yet why this isn't already. Still don't yet see why it's not already implicit by just writing the interval notation. Because wouldn't the statement, like the definition, the proposition, fail if there are points outside of the neighborhood around A that don't satisfy f of x minus b less than epsilon? See, okay, I'm glad that somebody else is also agreeing with me that, like, Levi's also saying, I'm not sure if we do need to write explicitly intersect domain f, because, like, Levi is literally agreeing with me. I also don't know. Like, I feel that I might be wrong here. And I want to know why. I think it is usually omitted from the book and assumed that we are already in domain. Rudin uses open sets in R, still working with real value functions. Right. And like, so does I think, if I understand this again, Rosenlicht. Like, yeah, you can define the limit in terms of open sets and then show that they're equivalent. Right, like I got you on that. But usually square root of x only has a one-sided limit. Yes, Zafarb. That's exactly what I was writing here. the limit of square root of x has a one-sided limit. It does not exist for the two-sided limit. What the hell? Levi, I'm extremely confused what you're talking about, dude, because... Levi. Cardinality of the real... Like, the real numbers are uncountable. That's Cantor's argument, right? Like, am I blinking right now? The whole... Like, that diagonalization argument shows that the cardinality of the natural numbers equals the cardinality of the integers equals the cardinality of the rational numbers, and that the countability of the real numbers is uncountable, that the cardinality is different, right? Which wouldn't be true without considering the domain. Okay, here we go. Happy Abe. There we go. There's the difference. Now I get it. Now I get what you're saying. It has a general limit. You only need both sides to be equal if the function is defined on both sides. I believe you on that. So then here, what you're saying, I gotcha. That makes sense to me. I think that this is a matter of definitions that we're talking about, like math as a game, math as a human constructed invention. I think that Taalman will say that the limit of square root of x as x approaches 0 does not exist. I think that you're saying that a more formal definition would say that the limit as x approaches 0 of the square root of x equals 0. Right? And I think either of these is valid. But I get why you would want this, and that might be how it's implemented in MathLib. Like that might be like the true definition that we've decided on, right? That the limit of square root of x is equal to 0. So my original example here was perfect, thinking of exactly this issue. I think in calculus, in like first semester calculus, we would say that it's only defined from the right, and it does not exist as x approaches 0. But then if we want to get more pedantic, like you said, which I do, like I do want to get more pedantic. I love that. Like we're 2 hours into this video. We've lost all the normal people by now. Let's get pedantic. I think you're right. With this, with your amendment to the definition, then you can define, where's the original definition? Then the square root of x, the limit as x approaches c of square root of x is 0 if we also require intersection with the domain of f. That makes sense to me. Yeah. I think that's where we are here. Right? Oh, dude, I cannot read LaTeX in Levi. I cannot read. Okay, so bar math BBQ. I can't believe that you all think that, like, you all are so math pilled that you can read LaTeX as if it were... No, dude, I can't read that. I get... So you're saying the completion of the reals has the same cardinality as the real numbers. Yes. I mean, isn't the... the completion of the rationals equals the the cardinality of the completion of the rationals equals the cardinality of the real numbers, right? That's what /bar means in what you wrote, right? I don't LaTeX, dude. I haven't LaTeX in 15 years, other than my resume. Is there a difference between the completion of the rationals and the real numbers? Oh, the complement. Oh, you're talking about the complement. The closure of Q is R. That's what I thought, too. Does bar mean closure? Is closure the same as completion? I don't know, man. I'm lost. I think by bar Q, he means irrational numbers. Yes, I meant the complement when I was writing /. Maybe I'm wrong there. Maybe I'm incorrect. I meant non-rational numbers. Because I can't just say X is in the real numbers, then you're, X is, like, the rational numbers are in the real numbers. So, I mean, I could say otherwise, but then I also have to define that F is from R to R or something. Yeah, I got it. Thank you, Happy Abe. That totally makes sense now. And I get why Spivak or Rudin or others would add that extra bit. Because, like, exactly like I said, I want to say that the limit of square root of x is 0 as x approaches 0. And that is true if you require the definition to intersect, like your neighborhoods to intersect with the domain of f. Well, yeah, like, why the hell would anybody... I just don't get why anybody would write LaTeX in ASCII. I mean, I guess, like, when we need to be, like, super, super precise. But you could have just said the closure of the reals or something, or the closure of the irrationals. Thank you for, getting the Unicode. Okay, so... Dude, this is super cool. I'm gonna, like, clip this, man. I feel like I'm gonna, like, email all these private schools again and be like, yo, checking in for the 4th time. Like, I'm learning a lot as a teacher. I have this really cool YouTube channel. Like, I hope you check it out sometime. We just had, like, a lengthy discussion about, the formal definition of a limit. And, I'm going to keep going. I'm going to write the other definitions now. Like, now that we've started this, here's, like, I think the next level, like the next step. It's super similar, but we do have this little twist that fixes this issue where we do want to write without saying one-sided limit that the limit of square root of x is 0 at 0. I have to think for a second. R equals... Yeah, I expect that R minus Q is uncountable. Absolutely. And that's what I mean. Yeah, R is Q union R minus Q. That's why I picked this example, dude. That's exactly why I picked that example. No, no, of course. My point is that R... Did I draw the thing backwards? My point is that there are infinitely many more irrational numbers than rationals. That's why I literally draw this red line as a solid red line. There are infinitely many more irrationals than rationals. Even though there are infinitely many dots here, this is perforated compared to... there's essentially 0, like, little dashed dots above compared to the number of real numbers. Maybe you read this backwards or something. I don't know. Yes, the irrationals and reals. That's my point. I hate when people write LaTeX in text too. I have a hard time understanding. All right, I'm glad you're with me on that. Yeah. I mean, now that I'm doing math all the time again, dude, I did not expect to be streaming this long today. Give me a second. I have a... Oh, shoot. Okay. Shoot. I'm late for a meeting. No way. This is more important to me. This is way more important to me. This is so much more important. Completion and closure are technically different, but in this case of Q, both result in R. Okay, right. Yeah, I was like, oh, shoot. They are different, aren't they? Is completion algebraic completion and closure? I don't remember. At this point, this is not even math. Yeah, that is what an Algebra 2 student would say, and I agree with you. I empathize with your point. Yeah, we are kind of more in the land of philosophy. Truly, we are kind of more in the land of philosophy in some sense. A mathematician would say, now we're in the real math world. Like, this is real math, but somebody else could say that this is philosophy, and everybody would be right. I didn't see your other example. I apologize, Happy Abe. I'll have to read that later. F of x is 0 on irrationals and 1 over q on rationals of the form p over q. This is continuous at every irrational and discontinuous on every rational number. Oh, wait, what? Okay, I'm gonna have to have another coffee for that one. Tea is not going to cut it. Thank you, Happy Abe. I'm going to try to look that up. I don't have time today to do Rosenlicht, which defines the limit on metric spaces. And I don't have time today to use Moncrief's or the other book that I forgot the author's name, which would define in terms of open sets. But there are two weirder, more formal definitions of the limit that are like a little more hardcore. So even though this book says this is an optional section, kind of, there's the intuitive definition that we all teach, and even Spivak still says, like, we can find values as close as we want to near that point. That is correct. It's just we need to make that more formal. And then once you start asking that question, it starts leading to more questions and more amazing facts that we can, like, can we define this for anything that has distance? That's what a metric space is. Like, can you define a more abstract concept of distance? Like, this absolute value of x minus a is the distance between x and a. You can abstract that to something called a metric. Then you can say, well, what if we don't even have distance at all? Like, can we define the limit without distance? Yeah, you can, and that's amazing. So you can study stock of a sheaf if you want to go even more general, but I actually literally have not even heard of that. So I'm going to say Rosenlicht, Moncrief's, and Levi. Levi defines the limit on the stock of sheave, or of sheaves. I don't know if anybody says a sheave. I don't know if that's Oh, a sheaf. Okay, of a sheaf. Okay. Levi defines it on the stalk of a sheaf. I literally have not learned that one. That sounds awesome. And yeah, we've lost Happy Abe even. So this is super cool. I wanted to write this last tip for me. So we didn't take any notes about delta epsilon proofs, rage bait, but we didn't take any notes on this, but I think that instead of that, we got something super similar. We got like even more technical and even more formal with this like rigorous definition that puts the limit on firm ground. And we saw a case where Taalman's definition would say that this limit does not exist. Whereas I think Spivak would say that this limit is 0. And both people are correct. Both people are correct. It's just you have to agree on the same definitions. Or the same audience, maybe. You can define the limit in weirder worlds as well. And you have to have the same definitions and the same formal presentation of these ideas in order to prove things like more complex examples or something. And a interesting example that Happy Abe came up with, thank you, dude, says this interesting example that I need to figure out. I've never heard of it. It kind of sounds like p-adic functions or p-adic numbers almost, but not really, because that has to do with the power of prime numbers, right? But I love this sort of stuff for sure. Happy Ape says f of x is 0. So I'm super glad that we got to get one of these weird counterexamples. Like, here's a definition of a function that you've never seen before. Like, for most calculus students, most engineers taking calculus are not going to see this example if you're taking a class out of Stewart's book. Like, I don't know. Don't at me, bro. Like, this probably is an exercise in Stewart's book, but like the AP exam probably doesn't cover this. Like, if you get what I mean. So I'm glad we got at least one example like that. And here's another example that's similar. 0 on the irrationals. Let's all agree that I'm going to write irrationals as R minus Q. And 1 over Q on rationals of the form P over Q. Oh, cool. Okay. Wait. Well, you're missing... Are you losing the domain, or are you just saying... No, you get every irrational this way, don't you? Oh, yeah. Okay. So this, for rational numbers, where x is some numerator divided by some denominator. Oh, neat. Okay. I haven't seen this example. Yeah, and you get every irrational number. It's just that it's like we strip out the numerator and we map the numerator to 1. And this is continuous at every... Neat. Continuous at... Oops. At every irrational. and discontinuous on every rational number. Dude, that's so cool. Discontinuous on every irrational. Yeah, I was looking for an example like this, dude. Discontinuous on every rational. What? Okay, I was looking for an example, something like this. Can you... So, are you saying that... Okay. Yeah, that makes sense. Neat. Okay, so you're saying that for any irrational... I'm just going to pick square root of 2. That this is 0. Right? And the limit, as x approaches anything, the number 2 of f of x does not exist. Right? Oh, that's super cool. I think I can see it, more or less. Is this called Thomas's function or Thomae's function? Is that a typo or... That is awesome. I don't know if I've seen that one before. You can study stock of a sheaf if you want to go even more general. Sheaf theory is very advanced, yes. Levi, hell yeah, man. Thank you for trying to help me understand stocks, but no, man. Not today, not yet. Someday. Happy Abe, you haven't studied algebra and geometry and you still know this stuff. F9X. That's a common mistake. Algebraic geometry is a super crazy complex math, like the most weird math ever. It is algebra like you're studying, and it is geometry, but it's very advanced, and it combines the two in some sort of way. That's my understanding. But it's very advanced graduate level math. You need to be very good at algebra, and you need to be good at geometry to study algebraic geometry. Yeah. Ooh, Zafarb. My cat is sad. Zafarb, thank you, dude. So I'll look into Hubbard's book. And Hubbard, they use a different definition, which leads to different results, like different limits existing or not existing. That's super cool. And Levi gives a +1 to Hubbard and Hubbard. Heck yeah. I haven't heard of that one. And it's common to define it like that in France. This is math is a human construct. Like in France, they define limits and calculus differently than we do in the United States, I guess. I don't know. I look forward to looking into this. That is super cool. Yeah, Happy Abe, that's what I was thinking, that there's gonna be irrational numbers with infinitely large denominators, which could lead to that limit thing. Yeah, that makes sense. Okay, Thomae's. I will look that up. I know that continuity is different, but it's been a while, so I wasn't ready to precisely state that this is continuity, like limits at every point. Like I know that continuity is we have more that we need to define for that one, but that will have to be next time. Thank you all. This has been a really fun 3 days studying calculus and working slowly through this book with you all. Thank you for joining this little study group, essentially, on Taalman and calculus. So we'll do 10 streams in linear algebra. Navneet, thank you. Bye. I'm glad you enjoyed this. Hit the like and subscribe, y'all, if you haven't already. I stream almost every day. I'm practicing math. I'm rotating through calculus, linear algebra, and representation theory. We're going to do a bunch of linear algebra, but then we're going to do 3 streams in representation theory. Then we're going to come back. We might do something random. Then we'll do 4 streams in calculus, 10 in linear algebra, 4 streams in representation theory. So we're getting closer and closer to an even match. High school math, undergrad math, college, graduate school math, right? High school, undergrad, graduate level. Cool. Thanks, everybody. I had a pleasure, it was a pleasure. I had a blast. Please leave a comment in the comment section. If you just want to tell people, if you want to give like a timestamp to where this discussion started, I think that this was so valuable, to somebody who's like learning calculus for the first time. Like, I think that this actually was a valuable discussion. So, cool. Thanks, everybody. And Happy Abe says, from what I see on Google, France's limits are basically continuity. Nice. I will look into that. That sounds really interesting. All right. Thanks for watching. Bye. I gotta go. Bye.